Welcome to the visit training session titled 1-Minute Visible Satellite Imagery Applications for Severe Thunderstorms. My name is Dan Bikus. Chad Gravel and Michael Bolin also assisted me in putting this together. Our objective is to learn how to utilize 1-minute satellite imagery that will be made operationally available in the future with GOES-R towards severe thunderstorm applications. GOES-R will be able to scan about 5 times faster than current GOES satellites, and because of that we'll be able to introduce new scanning routines. The two routines that we anticipate to be used most frequently will be these two, the full disk every 5 minutes and the flex mode. The flex mode is what we're primarily concerned about in this training session. With that mode we'll have full disk every 15 minutes, CONUS sector every 5 minutes, and then this mesoscale will have various sectors, either 2 sectors every 1 minute or 1 sector every 30 seconds. And that means we'll be able to use the satellite imagery in new and exciting ways that we just haven't been able to do in the past. Applications of that 1-minute visible imagery for severe thunderstorms can be broken down into a couple categories. First, in the pre-storm environment, we can use it for mesoanalysis, identification of air masses and boundaries with available surface observations and objective analyses. And then the other category would be monitoring the changing environment during the nowcast to warning decision-making time period. And in that sense, we mean continue to identify the boundaries and air masses, monitor interactions between boundaries and storms. It's important to consider storm motion relative to the boundary orientation. That's something that I'll list here as well. And note the effects of outflow on the near storm environment. And also identify potential satellite severe storm signatures. What do we mean by satellite severe storm signatures? Well, if we look at this conceptual diagram of a supercell thunderstorm with its overshooting top, we have above anvil cirrus, and here's our outline of our back-sheared anvil here. Here's the flanking line of interest, and then typically downshear of that, or you say to the east of that, we may see our inflow feeder clouds, which form within converging inflow near the strongest updraft. And Becca Mazer, in a study, found that there's a 77% chance of severe weather within 30 minutes if you observe these inflow feeder clouds. If you don't see the inflow feeder clouds, it doesn't mean the storm is not severe. So much like the enhanced V satellite signature, think of this as an added bonus. If you do see it, then you can really utilize that information in your warning decision-making process. Conversely, over here on the upshear side of the flanking line, or typically towards the west, you may see these lines of towering cumulus that form above an invigorated RFD. Not necessarily going into the storm here, but you may see them forming above the RFD here and moving in the direction towards the central part of the updraft over here. So if you see either of these signatures, understand that that storm is going through an intensification or maybe at its mature phase, and that it's something to weigh in your warning decision-making process. The first application for analyzing severe thunderstorms with 1-minute visible imagery starts with the pre-storm environment, doing a mesoanalysis, identifying air masses and boundaries. And we've done quite a bit of this in the past in terms of visit training sessions, and I list 3 of them right here. Next, we'll look at an example of the pre-storm environment analysis. Here's an example of looking at the pre-storm environment, doing a mesoanalysis. Now, this particular case doesn't make use of 1-minute imagery, but we want to start up here by looking at this particular case, and then next we'll be looking at 1-minute imagery applications. So if we look at this particular case, you can see there was a low towards the southwest portion of the screen here over extreme southwest Nebraska, and extending northeast of that we have this warm front that was reinforced by an outflow boundary from an MCS that you can see early in the loop. It kind of pushed towards the south early on, and then it moved back towards the north as a warm front into southeast South Dakota during the afternoon hours. So this is a classic example of looking at satellite imagery for analyzing the pre-storm environment, the various air masses and boundaries that we see here. If we go ahead and stop the loop and move it a little bit later to during the mid-afternoon hours, let's go ahead and stop it right here. Here we can easily analyze our boundary of interest. South of that boundary, we can see these unstable cloud streets that are oriented parallel to the low-level winds. These would be our this would be the unstable air mass south of the boundary, and we have very warm temperatures and high dew points, as we would expect in our warm sector. So then we go north of the warm front, and we can see these stable wave clouds in southeast South Dakota extending into Minnesota, and those would be indicative of a stable air mass. And these tend to orient themselves perpendicular to the flow at the inversion top level. So think of that as the region we would identify as our stable air mass, and then our unstable air mass to the south. And then if we go back to our looping imagery here, we can see a number of interesting things going on in the warm sector here as well. We can follow this north to south oriented boundary of some sort within the warm sector that's moving towards the east, and interestingly enough, it extends back and intersects with the warm front, the northern tail of it, right around here, where we see that initiation of a thunderstorm going up later in the loop here. So at the northern portion of that, a little bit later on, it initiated this thunderstorm, and it looks like we have towering cumulus at the very end of the loop. Let's go ahead and stop it at the end of the loop right here, and it looks like we have imminent convective initiation along that segment of the boundary down here. So these are the type of things you would look for in the mesoanalysis, the pre-storm environment. Look at the different air masses that we have and the boundaries and what role they may have in terms of the forecast, the nowcast period here for severe thunderstorms. Also keep in mind the orientation of these boundaries with respect to storm motion that you expect. That's very important. We just looked at the pre-storm environment, and that will substantially increase your understanding of doing that mesoanalysis when you have that additional 1-minute imagery. You'll have a better contextual understanding of what's going on with the additional imagery. The other major application with the 1-minute imagery will be to monitor the changing environment during the nowcast to warning decision-making time period. And we'll go ahead and look at a couple of different events here, and these two events had some papers associated with them, so if you're interested in reading the entire paper, we list the references here. Here's the first case that we'll look at. This is from 31 May 1996 during the GOES 8 science test. 1-minute imagery, actually 30-second imagery was called for on this particular day, and the storm of interest is this one right here. We're looking at eastern Colorado, western Kansas is over here, and this storm had a number of signatures on it that took place in the 1-minute imagery that you could really only see in the 1-minute imagery because they were occurring on such short time scales. So let's go ahead and stop the loop and advance along. This particular thunderstorm right here, we can see our flanking line quite nicely associated with that. Then if we go ahead and advance it right here and highlight this region, let me go back and forth. So there's 2240 UTC, 2241, 2242, and then 2245, just 3 minutes in between here, between 2242 and 2245. We see the sudden appearance of this stratocumulus cloud right here, and associated with that was an outflow from this particular storm just to its northwest, and a 70-mile-per-hour wind gust was reported with the arrival of this appearance of this stratocumulus cloud here. So it played an important role. We got a severe wind report associated with this, and you can see the result of that outflow very nicely here. Now if we go a little bit later, what happens is we still have that outflow boundary that we can see right here, and then over here we can see this particular storm quite well defined over here, and what's going to happen next here is this outflow boundary is going to move back towards the updraft, the main updraft of this storm right here. So let's go ahead and advance along with my cursor, and you can see the outflow boundary right here moving towards the southwest, and as it interacted with the main updraft of the storm right here, a tornado was spotted right at that particular time. As that outflow boundary merged with the main updraft of this storm, a quarter-mile wide tornado was reported with chasers on the scene. So this is an example of features that you can see in the satellite imagery that are happening on very short time scales, less than 5 minutes, in this particular case 3 minutes. You can follow it along very clearly with the high temporal resolution visible imagery here, and they're having real effects here. This, in terms of its severe wind report, and then also the interaction of this boundary with the storm to produce a tornado. Our next case is from 24 July of 2000, and this was during the GOES 11 science test. And what I want to demonstrate here is a comparison between RSO imagery that you would see versus 1 minute imagery that you would see. So what I did was I took the 1 minute data and selected times that would have been scheduled for RSO, so 8 images per hour in other words. So let me go ahead and start the loop, and a couple things to point out. There was a north to south oriented convergence line, approximately oriented like so, and there had been an outflow boundary that extended like so. And what happened is a thunderstorm tried to initiate right around here, and it was a failed attempt. It didn't get going. However, when it tried to go a little bit further to the northwest, when it was along the two boundaries, the intersecting boundaries, thunderstorm did initiate. So again, in review, this is how it would appear in RSO, 8 images per hour. And let's go ahead and stop it. Advance forward here, and here's that first attempt at convective initiation, and notice that it does not sustain itself. And then what happens as it intersects with the other boundary, the north to south oriented convergence line. The key for looking for convective initiation is the shadows, the anvil cirrus projecting a shadow here, and we can see that at 2125. So if we go back, we don't see it right here at 2115. Next available image at 2125 does indicate the anvil cirrus shadow, which would indicate at this time, 2125, that we would have convective initiation. Let's compare that to the 1 minute imagery next. Here's the 1 minute imagery, and I'll go ahead and speed up the loop a little bit. And as I show this, just notice how everything is more contextual now. You can see so much more details in terms of the 1 minute imagery. Now you can see much more continuity in the loop. For example, the first attempt at convective initiation over here, you can really see that in terms of the bubbling cumulus, towering cumulus that tried to get going and then failed. And it just appears that much more easy to see here in the 1 minute imagery. And then the place where convective initiation did occur, further to the northwest, it just appears that much more obvious here when you have the 1 minute imagery. It just makes sense. You have more imagery to look at, and from a contextual point of view here, you can really hone in on where cumulus is trying to go up and eventually does make it up here in terms of initiation. So let's go ahead and focus on convective initiation with the storm in South Dakota. So we're watching this area right in here, and we'll go ahead and advance along each minute here. And you can see the bubbling cumulus here. This is at 2120. You can begin to see signs of convective initiation much earlier here. By this time, you can clearly see anvil cirrus projecting a shadow right here, which would indicate that we have convective initiation that has occurred, and really you start to see it maybe a little bit earlier right here, where you start to see that shadow being cast. So in this particular case, with the 1 minute imagery, our convective initiation time can be discerned at 21:20. Let's look at greater detail at the time of convective initiation for the storm of interest over South Dakota. At the top, we have our image time, and this would be the image time where we first discern convective initiation. At the bottom, we have display on AWIPS, which is actually just as important. So in our 15-minute scan mode, at 21:30 image time, we would first discern convective initiation, and it takes about 20 minutes for display on AWIPS. So this is when you would actually see it. Next, we go to the RSO schedule, which is about 5 minutes, and as you might suspect, it's an earlier image, about 5 minutes earlier than the 15-minute mode. And importantly, it takes about 7 to 8 minutes to display on your AWIPS, so we display that lag here of approximately 8 minutes. So this is the improvement from the 15-minute mode when you would actually see it on your AWIPS. And then finally over here in the 1 minute, this would be what would be available on GOES-R in the flex mode at 1 minute or even 30-second intervals. And our image time here would be 21:20, which is obviously the earliest of the others here, quite a big difference. But the really big game changer here is when you would see it on your AWIPS. The time delay is going to be approximately 1 minute. And notice just the huge improvement over the previous times with the 15-minute or the RSO mode. Because of this is really a game changer, and the reason for that is you'll be able to use it in ways you haven't used it in the past. For example, in the warning decision-making process, you can now get this fast enough to actually discern these signatures in the imagery and use it in the warning decision-making process, in addition to really fine-tuning the Prestorm Environment, Mesoanalysis like we've been talking about here. So this is the big improvement here, this 1 minute delay in terms of when going from your image time to your display on AWIPS. Now let's pick up where we left off. This is at 21:36, and I'll go ahead and start the loop here. So it's looping at 1 minute intervals, and we can see how this storm progresses along here, moving towards the south. And the point we made earlier was the convective initiation around 21:20 here in south central South Dakota. And then just after that, you can see some indications on the southern flank of the storm of inflow feeder clouds right around here. And then a little bit after that, you can clearly see signs of invigorated cumulus back here, towering cumulus above an invigorated RFD on the back side of the storm here. So again, this all is, it's that much more easy to see when you have the continuity with the 1 minute imagery. You can really get a time sense of what's going on, a contextual comprehension of what's going on, increasing your situational awareness. And let's go ahead and just describe a couple of the features. So I can describe it in looking at a couple static images here. So the inflow feeder clouds, like we mentioned before, would be on this side of the storm since it is moving towards the south, and you can see those right around here. And then if we advance in time, you can see the towering cumulus on the back side of the storm right here above the invigorated RFD. And those first really appeared right around 2240, which is right around this time. And then soon after that, we got our got a baseball-sized hail report right around this time right here, 2248. And again, you can see those features on the back side of the storm, indicating that the storm is undergoing intensification or nearing some mature phase here. A couple minutes later, right around this time, first tornado report, and there were some later tornado reports as well. As you go a little bit later, you can see those actually go away as it approaches the South Dakota border. And the next time series that we'll look at, we'll pick it up as it goes into Nebraska. So here we pick up where we left off with the storm moving into Nebraska. And notice as it moves into Nebraska, we get the towering cumulus on the back side of the storm here above that invigorated RFD. They become more established once again as it moves towards the south. Get another tornado report at 0047 UTC, which would be right around this location here in Nebraska as it continued to move towards the south here. So the other thing I wanted to point out is at the storm top level, you can see what appears that it may be rotation at storm top level. If you look very carefully at a storm relative loop, what you'll see is a storm top divergence here, and maybe storm top rotation, but really the key signature is that divergence that you see at storm top level. So that's another thing that you can see in the 1 minute imagery here. Finally, in conclusion, here's the references once again for the papers that dealt with the imagery that I just showed here, as well as another paper that deals directly with rapid refresh information with the GOES-R that's coming up here. So the theme to take home here is that with this new technology, this 1 minute imagery that will be available, you're going to be able to utilize the imagery in ways that you just haven't been able to do in the past, because there will be that much more information, and you'll be able to receive it in a timely enough manner to use it during the warning decision-making process. And also, like I said, during that pre-storm environment, it's just going to appear so much more obvious now in terms of a contextual appearance of the things that you're looking at with the 1 minute imagery. They're just going to really stand out and make that much more sense and really raise your awareness of your situational awareness on these days where you're expecting severe thunderstorms. That concludes this training session. If you have any questions or comments, please let me know via email. Thank you.